Hi there, it's Katie with TutorPug, and I wanted to take a minute to go over the domain, especially with respect to rational functions in pre-calculus. So the domain, as you've probably been told, are all the values of x that you're allowed to put into a function, or all the values of x that the function can have. And sometimes you scratch your head and go, well, why can't I put in anything for x? And the answer is, well, sometimes there's things that are illegal in math. You cannot do certain things in math because they yield an answer that's undefined or an answer that's not real. So one of the big ones is if the entire value of a denominator of a fraction is 0, that won't work, that's undefined. Also, if you try to take the square root or the even root of a negative number, that's a not real answer. You get into imaginary numbers. So what we want to avoid for now are having the entire denominator be equal to 0, or putting something in for x that would yield a negative number under a radical sign with an even root, a square root, a fourth root, something like that. So for your purposes, the domain of a function is all real numbers, which in interval notation, which is very important, interval notation says negative infinity to positive infinity with curved parentheses. The domain of your functions for now are all real numbers unless one of three things happens. You either have a function that has a variable in the denominator, or you have a function that has a variable under a radical sign, or you have some combination of both of those happening, and I've put many examples of those over here. So you could have something like that. So you need to know what to do in any of these given situations. And it's very simple. It's just some steps that you have to memorize. Sometimes you have to memorize things in math. It's how it works. Sometimes you have to memorize rules in English. It's how it works. Sometimes you have to memorize dates in a history class. It's how it works. So if you have a variable in the denominator of a fraction, and that's the only situation that's happening, we'll start out with baby steps. If that occurs, the way you find the domain is we're trying to figure out what number or numbers we can't plug in. So if you have a variable in a denominator, you take the entire denominator and you set it equal to 0. And then you solve for x, and then you say x can't be that. And then you check yourself. If I plug a 10 back into this equation for x, 10 minus 10 is 0, 0's in the bottom, that's bad. So in interval notation, you must become comfortable with interval notation. Think about a number line. Nothing wrong with a number line. I use number lines all the time. If I had a number line and there was 10, this says I can have it, I can have it, I can have it, I can have it, I can have it. Oh, nope, can't have that. I can have it, I can have it, I can have it. So sometimes it's easier to translate a number line into interval notation than it is that statement. So this translated into interval notation says I'm allowed to start with any value of x as far left on the number line as I want to. And that's defined as negative infinity. And I can pick any number from negative infinity all the way up to the number 10, but I can't have 10. Curved parentheses means you can't get that number. You don't get to grab it. And then I say, okay, I'm going to do that along with, I can have anything over there along with, or union, anything over here. And that says start at 10 and go up forever. And then we have to close these guys off, and infinities, whether they're negative or positive, always get a curved parentheses. So the way you deal with a variable in the denominator, set the denominator equal to 0, solve for x. X can't be that number or those numbers. That's problem number one. Problem number two is if you have a variable or variables underneath a radical sign. And we're going to assume right now that it's an even root, a square root, a fourth root, a sixth root. We won't worry about cube roots. They are not a problem. The thing you need to memorize to deal with this is you take the radicand. The radicand is the entire chunk of stuff that's under the radical sign. So if you have a variable under a radical, not in a denominator, you take the radicand, you make it be greater than or equal to 0, and you solve for x. Subtract 6, 2x greater than or equal to -6, divide by 2, x greater than or equal to -3. So that says if I walk up to this with a -3, -3 times 2 is -6 plus 6 is 0, square root of 0 is okay, and it's 0, and that's a legal value. If I pick anything bigger than that, I'm also okay. So again, if we go to our number line, I'll get us some room up here. If we go to our number line, this says I start at -3, and the equal bar means I'm allowed to grab it. Close dot. And I can pick any number that's bigger than -3. So in interval notation, that says start at -3 and go up forever. Since that's a closed dot, a bar, you grab it and you never catch infinity. If you have a radical in a denominator, you're going to do a very similar situation here, but instead of making the radicand be greater than or equal to 0, you just set it greater than 0. Because again, you still can't have 0 in the bottom, so I can't put a number in that's going to make this be equal to 0. It's okay to take the square root of 0, the outcome is 0, but I can't have that in the denominator. So I would solve for x, and then in terms of interval notation, this says start at -5. You can't have it. No equal bar. You're not allowed to have that. But then you can grab any number bigger than that. So those are the 3 different big scenarios you have to worry about. And then sometimes you have them combined, and you have to keep the top and the bottom happy at the same time. So these can start to be a little challenging. Let me give us some room. So I have to pay attention to what number or numbers are going to make the bottom happy and the top happy. So here I have a variable in a denominator, and the rule says set that equal to 0, solve for x. X can't be that. So that just takes care of this piece. So I will go to my number line, and I'm going to plot 2 on that number line and say to myself, no, not allowed. What's the one number that makes the denominator unhappy? Now we'll look at the numerator. We got to keep the radical sign happy. The radical sign is in the top, so we take the radicand and we make it be greater than or equal to 0. Solve for x. For x greater than or equal to -8, x greater than or equal to -2. So this on the number line, I'm going to go to -2. I'm allowed to grab it, and I can pick any number bigger than that, but I still can't have +2. +2 makes the top happy, but it makes the bottom unhappy. So we have to make everybody happy at the same time. In interval notation, from left to right, this says start at -2, and you can grab it. And you can pick any number up to 2, but you can't have it. Along with, we're going to pick back up at 2 and keep going to positive infinity. That statement the numbers that are in those subsets keep both the top and the bottom happy. So that would be the entire domain of this function. For this guy, the only thing we have to worry about is the denominator. Because a variable in the numerator, no problem. The tops of fractions can be equal to 0. It's not an issue. It's the bottom that we worry about. So I take the radicand. Since the radical sign is in the denominator, I just say greater than 0. I solve for x. So this domain says I can start at -4, but I cannot grab it. There's no equal bar. And I can go up forever. Now this last one has lots of moving parts. Variables under radicals in numerators and denominators, and we have to keep everybody happy at the same time. So I'm going to start with the bottom, kind of habit, I always deal with the bottom first. Under a radical in the denominator, which means x plus 4 greater than 0, no equal bar. Solve for x. So the part that makes the bottom happy is -4. Can't have it. Yes, you may pick anything forever and ever bigger than -4. Fine. We'll see what makes the top happy. 4 minus x greater than or equal to 0. When the radical sign's in the top, we can do equal to 0. Solve for x. So this says I can start at 4 and I'm allowed to grab it and I can pick any x smaller than that. That's what makes the bottom happy. So the total domain of the entire function are the overlapping parts. We got to keep the top and the bottom happy at the same time. So just here to here. Doesn't look like very many numbers, it's actually infinite numbers, but those are the only ones I get. So that says, this guy's domain says I can start at -4, but I'm not allowed to grab it. And I can go up to 4, and I can have it, and that's it. Things beyond to the right make the bottom happy, but the top sad. Things to the left make the top happy, but the bottom sad. It's only that Goldilocks piece in the middle that makes everybody happy. So I hope this helps explain some of the domain. I would expect to see them on upcoming quizzes and tests. It's a concept that keeps repeating itself over and over in math. So study, 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 so Mr. A will be your buddy.